Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
This episode is proudly sponsored by Metageek. For more than a decade, network professionals have used Metageek Wi-Fi tools to deploy, maintain, and troubleshoot wireless networks. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Metageek brand hardware and software. Hey everybody, welcome to a brand new episode of the Clear to Send podcast. Today, it's just going to be me, Roel, your host, and I wanted to start off by talking about some of the news that came out from, I think this came out from CES. It was just announced on January 8th, 2018, and the Wi-Fi Alliance is introducing some security enhancements, which is actually going to be around WPA3. And as you guys know, WPA2 has this widespread adoption. It's installed or actually configured everywhere, such as PSK. And it's PSK is just used absolutely everywhere. If you go to places such as restaurants, you can see that PSK password just printed on a piece of paper. A lot of places use PSKs for their guest networks. So whenever the guests arrive in an office, they join a separate guest Wi-Fi network with a PSK that protects it. And so Wi-Fi Alliance is introducing WPA3, which they will certify devices and equipment around this, and they're saying it's going to emerge in 2018. So I'm looking forward to seeing more information come out of this. I think it's a great enhancement to Wi-Fi. We need to focus on security first. And because of IoT, security is now becoming more relaxed because IoT devices just are terrible when it comes to security. They need to be protected better, improved, and WPA3 is supposed to help with that. So it's going to allow users to choose more complex passwords, have complexity built into that, and they're going to simplify the configuration of security on devices that are basically IoT devices. And another feature which is going to come out with WPA3 is going to strengthen the user privacy in open networks. And they're going to do that through individualized data encryption and also enable 192-bit security suite. So I'm looking forward to that, especially around protecting user privacy with open networks, because that is always a challenge for, say, your guest networks. Again, you want to make them open or easily accessible to your guests. So you're either protecting it with PSK or you have it completely wide open and you're using some other method of filtering. You probably have a lot of firewall rules applied to that. You're segmenting that user traffic away from your network. You got it isolated. And a lot of times it's just left open. So looking forward to see how we can improve user privacy through this individualized data encryption. And so we should hear more about that later on in 2018. So the main topic of today's episode, if you're following along with the previous episode, I spoke about Cisco NDP, or Neighbor Discovery Protocol, and how that is the language of Cisco access points. So I'm going to take it on to the next step, and we're going to discuss Cisco RRM DCA, or Dynamic Channel Assignment. Now, Dynamic Channel Assignment, it is a core piece of Cisco's RRM, or Radio Resource Management. It runs an algorithm that dynamically changes an access point's channel, the channel that serves the clients on, and that's based on multiple parameters, and altogether those parameters are collectively called a cost metric. And so that cost metric will determine what channel an AP will serve clients on, either on the 2.4 or the 5 gigahertz. Now, to take a look at DCA, or dynamic channel assignment, if you have your Cisco controller, if you click on the wireless navigation heading at the top, and then on the left navigation, you'll see 802.11 ANAC, and you'll also see 802.11 BGN. If you expand either of those, you'll see the subsection of RRM, and within that section, there is DCA for dynamic channel assignment. And so that's where you begin to configure DCA. And what I wanted to do was just briefly touch upon the settings that you can select from here, because there's quite a bit of settings, and you want to know what does it mean and what kind of impact it creates on your wireless network, if any, right? So the first thing you want to know, or you'll notice, it's along the top there, is the channel assignment method. And there are 3 methods in which channel assignment works, and that's automatic, freeze, or just off. Now, I don't want to hear any jokes. Some people will say turn it off. But hey, you've got your Cisco controller and you want to take advantage of it and advantage of the features that you're given here. So we'll go through these 3 settings real quick. Automatic is that it'll run the DCA algorithm at an interval. And so by default, if you don't change this setting, it's going to run every 10 minutes. And then you'll also see to the right of that interval is an anchor point. And that anchor point is used to set the time of day that the DCA algorithm will start. So if you have that set to 0, that's going to start, I believe, at 12 a.m. And so this interval is really short by default, 10 minutes. I actually set mine much longer because I don't like channel changes that often, especially in an environment where there's going to be a lot of people using Wi-Fi and they need to rely on it. There's other, you might be asking a question like, well, what if there's an issue that the AP should change channels? Well, we'll talk about that later in a bit. The second method is freeze, and that does not run the DCA algorithm unless it is triggered. So you can freeze it and then manually trigger the DCA algorithm, which it'll run through its algorithm and then tell the APs which channel they should be on. And then the third option obviously is off, and that just disables the use of RRM and its auto RF capabilities. Now, there could be various reasons why you want to do that. You could turn it off because you don't understand how RRM works. You could turn it off because it's not working for you. Or you can turn it off because you don't trust it. So there's different reasons why. At least you have the capabilities of running it or not running it. Now we move on to the next configurable option, which is avoid foreign AP interference. This option, if you enable it, allows RRM to take the surrounding neighboring APs that are not part of your network into consideration of within the algorithm. And then RRM will create a channel plan to help mitigate any kind of co-channel interference with those neighboring APs. And so one of the things that's important with this setting is, for one, you want to, if you've got a large wireless network, you want to be sure you've got it configured properly so that your controllers know if the neighboring APs are part of, say, another controller, and you want to configure your mobility correctly so that they know that. One way to use this is if you've got a very congested environment, although this is something I probably wouldn't turn on off the bat, not without really looking at your environment, is because if you've got a crowded environment, there may be no channel to to avoid, although I don't know the very deep specifics of the algorithm and what metric it's going to use. Say maybe a neighboring AP that's not yours is on channel 1, and then maybe there's another neighbor that's also on channel 1. It might try to determine, okay, how severe is that channel to your users. But that part I don't know. But that option, avoid foreign AP interference, is an option you could enable. I would test it out if you're not sure how it interacts with your environment, but it's worth looking at if you're trying to mitigate some sort of interference with your neighbors. Now the next option here is avoid Cisco AP load. Now this option allows RRM to consider traffic load on an access point to help build, say, a better either channel plan or allowing devices to select a better AP to associate to. Now, this feature I do not enable in my environments because it is very difficult to tell a device which AP to join exactly, because the clients are the ones that determine which AP they're going to roam to. So the way I imagine this feature works is that you have a device that is trying to join or associate to an SSID, and an AP could just suppress the responses so that another AP could respond. But again, this is not a feature I enable. I have not tested it, and quite frankly, I just don't believe we should enable this type of feature on the infrastructure and just allow the clients to decide which AP they should roam to. Now, the next section within DCA here is, losing track of which features I'm talking about. We've got avoid non-802.11a or b noise. And now the option here is either on the 5 gigahertz radio side or the 2.4 side, depending on which setting you're changing. And RRM will take interference on the channel into consideration for the channel plan. And what this really means is interference is really anything that's coming from a non 802.11 signal. And so it'll take that into consideration into the algorithm and determine, okay, maybe this channel should be avoided near or around these APs. And so those APs will not use that channel in the DCA algorithm. Now, another setting that's kind of interesting to me is the persistent device avoidance. Now, sometimes there is, let's say, a non-Wi-Fi device that's interfering and affecting your users on your wireless network. DCA can help mitigate this issue if you have avoid persistent non-Wi-Fi interference option enabled. And RRM receives this information, this interference, from clean air. So clean air is part of RRM. And if that interference is creating a negative impact on your wireless network, RRM can issue a channel change to avoid it. And what's really cool about this feature is if you can turn this on, you can actually view persistent devices using the user interface. And the way you do this is you're going to view the details of the AP, and at the bottom of the page are all the persistent devices being tracked. And it includes the class type, on what channel that interference was heard on, what the duty cycle is, the RSSI of that signal, and when it was last seen. So there's a timestamp. So I think that's a really interesting feature of RRM DCA and also of clean air. And so they take a lot of the RF, a lot of everything in the environment into consideration of this algorithm to help build a more robust wireless network. So the next topic I want to go to is DCA channel sensitivity. Now, DCA by default will be set to a medium channel sensitivity, and that's 15 dB for 5 gigahertz and 10 dB for 2.4 gigahertz. And this is what is considered the DCA sensitivity threshold. And by changing the channel sensitivity, let's say we change it to high, then a cost metric of 5 dB better will recommend a channel change. And so this sensitivity level, I would not recommend you change it to high. Start it off at low or even medium, because this could trigger a lot of channel changes in your environment. And I'll get into that in a bit, because you don't want to have too many channel changes in short intervals, because that's going to be a disruption to your users and it's going to be noticeable. This episode is proudly sponsored by Channelizer with Cisco Clean Air from MetaGeek. Channelizer with Cisco Clean Air is software that provides remote access to the clean air radio on your Cisco access points, so you can troubleshoot spectrum issues from your desk, down the hall, or halfway around the world. Using Channelizer, you can find and classify interfering devices automatically and view the duty cycle of each unique transmitter from the perspective of your Clean Air AP. Channelizer provides a complete picture of your RF environment and easy-to-read visualizations, so you can identify and fix issues quickly. No longer will you need to go on-site or even get up from your desk to troubleshoot spectrum issues. To thank you for supporting our friends at ClearToSend, MetaGeek is offering a limited time 10% discount to all listeners. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Channelizer with Cisco Clean Air. Now, the next setting that we're going to go over here is the DCA channel list. So when we talk about channel changes, how does DCA know what channels to even use? Does it enable all the channels? It doesn't. So to have DCA dynamically set a channel, it must be enabled in the channel list. And you could specify which channels for DCA to select from. You could, if you know there's specific channels you can't use, you can just leave them out of the channel list, and DCA will not include them into the algorithm or include them on the list for APs to select. So you could select all of the channels if you'd like, or which includes also the Uni2 channels. So enable all the channels there if you'd like the full range of channels available to you, especially in the 5 gigahertz range. In the 2.4, for us, just enable 1, 6, and 11. So in addition to that, right underneath DCA channel sensitivity is the channel width. And this is DBS, or dynamic bandwidth selection. And so RRM has a flexible way to assign bandwidth to APs. And so as they analyze the RF, they can say, hey, you could utilize a wider channel width. And this is perfect for environments where there maybe aren't many neighbors at all. Maybe you don't have surrounding neighbors to interfere with your signal. Well, not interfere, but you basically have more channels to use, more bandwidth also to use. And so you could have, say, your channel width selection set to as low as 20 megahertz, which is what I really recommend. Or you can go as high as 160 megahertz. Or there's another option called best. And so the algorithm will just determine what the best channel width will be in that environment for that AP. I have mine set to 20 megahertz because we do a lot of high density areas, so we need the channel reuse and the capacity. So 20 megahertz is what I'm using. Some people use 40 megahertz because they're able to. You'd be like on the edge if you're using 80 megahertz or 160. And kudos to you if that's working out perfectly for you. And it really depends on your environment. And also, one thing to know is you might be asking, well, if I have an AP that doesn't support 80 megahertz or 160 megahertz channels, what's going to happen? Well, Cisco knows the AP models. They're the ones that make the APs, right? So they know whether that AP is capable of doing 80 megahertz channel widths or 160 megahertz channel widths. It just simply will not configure that AP to use that width if it doesn't support it. So it'll just use 20 megahertz. So you can either, again, use 20 megahertz channel widths, 40, 80, 160, or if you're feeling lucky, you can just have the controller pick the best channel width for you if you're feeling like taking a risk. And so underneath that, you'll also see the DCA channel list. I'm trying to paint this picture for you of the settings. So I'm going from top down. If you don't have a controller, just try to imagine these settings from the top, and I'm going down these settings. What's really interesting, if you log into the controller through command line interface, you can see the controller dynamically set these channels. And that command, it's a debug command that you could use on the controller. It's debug airwave-director channel enable. And so you'll see RRM spew out all these debug commands. It'll use the MAC address of the AP. And what you'll see in my example, which I'll put up on the show notes if you guys head over to cleartosend.net, you'll see that for a specific AP, the controller, or specifically the algorithm for DCA, is going to set the channel width accordingly to what it thinks it should be, depending on what it resulted from the algorithm. And then it's going to send a final channel assignment to that AP, and you could see that command. It'll say final channel assignment. It tells you the channels. Looks like for me, it's a 40 megahertz channel. And then it'll say configured on AP, then the MAC address. So you can see that in real time if you wanted to using that command. Again, that's debug airwave-director channel enable. And then from again, the command line view, it is possible also to see when the last channel assignment was set. And you could use that command on the controller. It's a show command. You do show AP auto-RF 802.11a for 5 gigahertz, and then the AP name. And what you'll see a lot of information, but the information we want is the channel assignment information. And you can see channel change count, how the last time how many times the channel has changed, and also a timestamp for the last channel change time, and then the best recommended channel that DCA is recommending. Now, if you wanted to see the 2.4 gigahertz radio, just swap out 802.11a for 802.11b. And in the example on the show notes, what I'll do is I'll truncate all the other information that we don't need and focus on the output that I want you to see. Now, the next setting that I forgot to go over was avoid check for non-DFS channel. Currently, I don't have that enabled on most of my controllers, but it is what it says. It's just avoid check for non-DFS channel when it's running the DCA algorithm. Now, one of the last options I want to talk about is the event-driven RRM. So the reason why we use controllers, or one of the reasons why people use controllers, is they might have a small number of staff members that can, say, try to mitigate a problem within an amount of time, right? So what we want to use RRM for is to help staff, help network engineers make the best recommendations and the best changes on the Wi-Fi network. And by doing that, we want to also have it react to bad RF, as an example. So with event-driven RRM, if you need that wireless network to react quickly and automatically to, say, bad interference, you would enable event-driven RRM or ED-RRM. And so if you have that enabled, an example would be a device that's using 100% duty cycle that's causing all of the rest of your nearby APs and clients to hold off on communicating over the medium. With event-driven RRM, it would allow an AP to make that channel change much sooner than waiting for the DCA interval to kick in. So if you had your interval, say, set to every 6 hours, maybe within those 6 hours there was persistent interference occurring, and what event-driven RRM with that option enabled, it would just kick in that change right away. And so with event-driven RRM, when you enable that, there are different thresholds that you can set, and they're defined by the air quality through clean air. There's 3 sensitivities here. There's a low sensitivity, so if air quality is at 35%, medium sensitivity, where air quality is at 50%, and high sensitivity, where air quality is at 60%. And air quality of 100% is good, and very bad is 0%. So the rogue duty cycle option also will allow you to set the percentage of duty cycle and rogue duty cycle to occur before triggering event-driven RRM. My recommendation here is to not set it to high sensitivity. You might want to make it a lower sensitivity, just so you want to be able to track this and be able to see how this works in your environment. So it's not something I'd recommend putting everything, at the highest setting. You want to make small changes to your controller and then see how your environment is after that change. So I wouldn't go into DCA and start enabling a whole bunch of features and then assuming that your wireless network is going to be working perfectly. So one of the examples is your DCA channel list. Do you want to enable, DFS channels on that list? You might not want to if you're consistently getting radar detection, because that's going to trigger your APs to back off of that channel and pick a non-DFS channel. So that's a disruptive channel change to your users if the devices, they're trying to communicate on channel that's changed and they didn't know about it. Now the controller should be sending a channel change announcement, but sometimes maybe a device didn't get it, or it was communicating and then all of a sudden there's that short drop of connection as the channel changes. Maybe you want to use 80 megahertz channel widths. I don't know. You want to be careful doing this kind of setting globally. Now, these settings are globally set for your 5 or 2.4 radios. So if 80, just because that option is there available for you doesn't mean you should always use it. But if you want to see what kind of changes occur on your network, you want to make those changes, one at a time, incrementally. Don't go and change every single setting just because it's available to you. You want to be aware of, say, your interval for your channel assignment methods. Maybe 10 minutes is too aggressive for your environment. You could set it a little bit longer, maybe every hour or maybe every 4 hours. And that's totally up to you. So again, that's just kind of the overview of Cisco RRM DCA, or dynamic channel assignment. It's something that I look at every once in a while, make some changes to see, if I create a positive or negative change, and have the tools to try to look into that. Of course, your best tool is going to be your end users. They're probably going to scream at you if you've made a negative change. So you want to be cautious. Maybe you have an environment too that will be welcoming these changes, and they're much easier client or users to deal with. But again, I'll leave the show notes. If you go to cleartosend.net, I'll leave up what I have describing each of these settings, and let me know what you think about DCA. Let's try to keep those comments civil. I know this is a touchy subject for a lot of people using RRM, but I feel that if you're using Cisco and you're designing your wireless network properly and you design with RRM in mind, then RRM can be very helpful for you, especially DCA, because I know it's helped me quite a bit, especially when you have a large network where you can't get to every single issue. Maybe I want event-driven RRM to kick in just so if there's interference and it's affecting people, I'd like that change to be automatic. Because we're always talking about automation, we're always talking about getting work done efficiently. This is one way to help us get there. And it's not a perfect solution. It does require having a very thorough understanding of how RRM works, and DCA is just one of the components. And so I myself am also getting very familiar with it. It's one of those things where you always got to go back to it, learn about it, because Cisco's changing it as often as they can. And they do have an RRM design guide, which I will link to in the show notes. I would definitely give that a look, give it a read. And if you run a Cisco network, read that guide to help you understand how you can make your wireless network better. A lot of people will just turn the knobs without really knowing what they're doing to their wireless network. So I highly recommend reading the RRM documents to understand what you're actually doing to your wireless network. And this is just part of the series that I have going on, talking about Cisco. Now, I won't be exactly perfect sometimes, but I'm trying to get the information out there to you guys and help trigger some conversations and discussions around this topic, and really just to help make our networks better, but through discussion and the tips that people have. And from here, we will talk more about Cisco RRM. Today, it was about DCA. Go and listen to the previous episode where we also talked about Cisco NDP, the language of Cisco APs. So there you have it. That is our episode today on Cisco RRM DCA. If you guys have any questions, let me know down in the comments section of the show notes, or you can hit us up on Twitter @ClearDescent. And once again, I want to thank you guys for listening. If you haven't already, go ahead and subscribe to the show on iTunes. That way you will get the new episodes automatically downloaded to your phone. There's no need to head over to the website and then hit play on the latest episode. It'll automatically be there for you, ready to listen. And that way, if you're, all of a sudden having to go on that trip, you have something to listen to and not have to worry about downloading something. So if you guys have any questions, reach out to me. I am on Twitter @Roel Dionisio. Again, I want to thank you guys for listening, and we'll see you on the next episode.